Okay, so today we're going to be talking about operations with sets. The title of this section is Operations with Sets. At the top of the last lecture, 2.2, I mentioned a type of Venn diagram that intersects in this way, and I must have done at least one example with two sets intersecting this way. Now, the focus of 2.2, though, was really on sets that are intersecting this way, things that are subsets of each other, or proper subsets of each other. So this was covered in 2.2, this kind of relationship. But what about this kind of relationship, where these are not subsets of each other, they're intersecting just a little bit. One is not completely encased in the other. So this is going to be the focus of this 2.3 section. Sets that intersect in this way. Okay, and what we call this area is we actually call it an intersection. We call this area an intersection. And we have a symbol for it. There it is. It's like an upside down capital U. It's called the intersection of A and B. Now, let's be technical. How do we write this in set builder notation? Set builder notation. A intersect B equals the set of all things X, so elements X, such that, now how would you describe this area right here? How would you describe elements in this area where these two sets are intersecting? I would say it's things that are in A and things that are in B, things that are in both A and B. So what we'll say is we're going to use our symbols from 2.1. X is in A, so remember that little symbol, that little, like a C with a, it's almost like a backwards 3, sort of. X is in A, and X is in B. That is the set builder notation for this intersection. Whoa. So what we have is we have a picture of A intersect B. I'll get rid of that question mark now that we know what to call it. It's a picture, symbol, right? The symbol to say what it is. We have a verbal, not verbal, but I guess just a colloquial, just a regular statement of what that symbol means. It's the intersection of A and B, where things that are in A and B at the same time, and then we have the set builder notation for that. Okay, so let's do example 1. Example 1 from notes. So this is following from the lecture notes that are available in Canvas. It says to find the intersection of the sets A and B. I'm going to shorthand this, so find intersection of A, which is equal to the set of letters that spell the word number. Well, numbers, so with an S. So 7 elements in A, so I could say the cardinal number of A is 7. And B is the letters that spell the word rule. So 4 elements in that set. The cardinal number of B is 4. But they want us to find the intersection, so this is what we want. We want A intersect B. And let's give it in roster notation. Because there's so few elements here, we can easily list these elements. So, what elements are in both A and B? Well, R is in there, is in A and B. U is in A and B. L is not, right? L is in B, but not A. And E is in both of them. Okay, now as a picture, what would this look like? So this is fine. This is the answer. Set A intersect B is these three elements. But what would it look like as a picture? If this was A and this was B. Whenever you're drawing a picture like this, you always want to start on the inside. Start in that innermost intersection right here. We'll put those three letters in there. R, U, E. That's the intersection. What's left in B then? Look at this, B, R-U-L-E. So what do I write inside of B here? Do I write R-U-L-E? No, I only write L. I only write L because R-U-E is already inside of B, it's just over here, it's stored in this part. So I have all four elements in B. Likewise over here in A, I'm not going to repeat R, U, and E. I'm just going to put the N, the M, the B, and the S. Because the R, U, and E are already accounted for here. Okay. So this is what the picture would look like for representing the relationship between these two sets, A and B.